The main renewable energies in use today are solar power, wind power, biomass, hydroelectric, geothermal, and hydrogen. Unlike many of the other renewable energies, solar power has absolutely no dangers because the only resource it uses is sunlight, and it has no emissions. However, its reliance on good weather and its poor efficiency drag it down. Although wind power is very clean, it's restricted by its dependency on its location and other factors such as its spinning blades caused by its design. Biomass's use of organic matter, which can be regrown again and again for energy, allows it to be very renewable. However, its emissions and need for destroying forests make it detrimental for the environment. Because of the high efficiency of hydroelectric power, and the low possibility of mechanical water energy ever going away, hydroelectric power is widely used. However, its introduction of invasive species to ecosystems make it very dangerous. Geothermal energy relies on Earth's infinite supply of heat energy. However, the holes drilled through the Earth in geothermal plants make the land around it unstable and prone to earthquakes. Hydrogen is the most abundant element in the universe. This, along with its high energy capacity and non-harmful emissions, make it the ideal energy carrier for the future and a very good type of renewable energy. So how exactly does the electrolysis of water work? The entire process can be written as two water molecules that is changed using electricity to two H2 molecules and an O2 molecule. It happens inside a cell with two electrodes, the anode and the cathode. The electrons travel from the battery through to the cathode, then to the anode, and then back to the battery. And the individual electrodes, oxidation and reduction take place. Both half reactions come together to form the electrolysis of water. A fuel cell is a device that can generate electricity through chemical reactions. A proton exchange membrane fuel cell uses a proton exchange membrane to generate electricity using hydrogen. It does this by channeling hydrogen into the cell. A catalyst then splits it into electrons and protons. The electrons must travel around the cell, through a circuit, and back, where it meets the protons who travel through the membrane in the cathode. From there, it meets with the oxygen, creating water. Now this is just what a homemade cell can do. A cell of larger scale can do much more if we work on some problems. The current ways of hydrogen generation and hydrogen storage are either not cost efficient, space efficient, or energy efficient. By researching alternatives, hydrogen could be a much more viable option. After that, well, hydrogen can be used for many things, including wastewater treatment. And though there are some obstacles, once we overcome them, the possibilities are endless.